Hello everyone and welcome to my channel. In today's interesting physics class, I'm going to show you how to find the cross product of two vectors. Without further ado, let's get down to business. Here we have two vectors, vector B. It has components in the x, y, and z, which are represented as I, j, and k. The I is for the x component, while the j is for the y component, the k is for the z component. If you look at here, you also have your c. It has components in the x, y, and z respectively, where I represents the x, the j represents the y component, while the k represents the z component. We have to find C cross B. We're going to find the cross product of these two vectors. I need you to understand something. When it comes to finding a cross product of two vectors, C cross B is not equal to B cross C. For example, some students they make a whole lot of mistakes when it comes to finding the cross product of vectors. They think it's the same when they change the order. If you change the order, you are also going to change your result. If your teacher or lecturer asks you to find A cross B, stick to A cross B, because A cross B is not equal to B cross A. If you do it the wrong way, you get the wrong solution, and that's not going to be nice on your grades. Now let's go ahead and solve this very problem. To find the cross product of two vectors in a very easy way, we just have to use matrix method, where I'm going to use the letters and the coefficient of these two vectors and represent them as matrices. What do I mean? I'm going to draw two lines here, and I'll pick the I. Here you have an I. I'll pick the J. You have a J. I also pick the K. You write it down here, the K. We have I, J, K, which is represented here, I, J, K. This is our row 1. This is our row 1. Next up, remember they said we should find C cross B. And C cross B is not equal to B cross C. They are not the same. If your lecturer says, like I said initially, find C cross B, do not say B cross C, because they are not equal. All right, let's proceed. Next up, you pick your C's. Your C, the first number or the number in front of your I is a 2. Where you see I here, you write a 2 below it. Let's now do for the J. Remember, we fill the C first. The C first. Next up, the number in front of the J is 1. You know, in mathematics, if you have something like x, this is actually 1x. Instead of writing 1x, you just write an x. Okay, so the number in front of the x is just a 1. In the same way, the number in front of the J is a 1. Okay, and for the K, which we're going to write here, the number in front of the K is not a 2, but a -2 or a -2. Below the K, we write a -2. We're done with the C. Let's now go for the B. Here we have an I. The number in front of the I, like I said, is a 1. This I stands alone, and the number in front of the I is just a 1. You write a 1 here. What about the J, which is for the B? The number in front of the J is a -2. You write it down here. And lastly, for the K, the number in front of the K for the B is a 3. Now we have formed what we call a 3 by 3 matrix. What makes it a 3 by 3 matrix? We have row 1, row 2, row 3. These are our rows. I, J, K is row 1, 2, 1, -2 is row 2, 1, -2, 3 is row 3. Let's now go for the column. Here we have column 1, I, 2, 1 is column 1, J, 1, -2 is column 2, K, negative 2, 3 is column 3. That's why it is called 3 by 3 matrices. That's what you're going to form if you're given two vectors that has components in the x, y, and z. Now, there is also one thing that you need to know whenever you are about to do this. You need to know that there are signs that are constant. And what are those signs? It's a plus, minus, plus. These signs are always constant whenever you are working on 3 by 3 matrices. Do not forget that you are going to use plus, minus, plus. The plus belongs to the I, the minus belongs to the j, the plus belongs to the k. That's how it works. And I'll show you how to use them in the course of our simplification. The next thing that you also need to know is that whenever you have 3 by 3 matrices, you can't just solve them like this. Your question should be, how can I break this down from 3 by 3 to 2 by 2? Remember, we are trying to find a cross product of C and B. This is a 3 by 3 matrix because it has row 1, row 2, and row 3. Now, the next thing that we're going to do is to break it down from a 3 by 3 to 2 by 2. Let's begin with the solution. How do you do this? You're going to use the I, the j, and the k to break this matrix down from 3 by 3 to 2 by 2. How do you do that? Let me show you. Here, I'm going to write it up here. This is equal to, I was supposed to write it here, but because of space, let me do everything up here. You first of all pick for the I. Here you have the I. You draw another line here to indicate that you want to fill certain numbers or symbols right here. For the I, right, to find what belongs to I. Now, let's say in simple terms, what belongs to I, okay? How do you do this? You hide the row where I is found, like I is found in this very row, okay? This is the row where I is found, and I is also found in this column, okay? So, if you hide this row where I is found and the column where I is found, whatever remains belongs to I. I repeat, to find what belongs to I, hide the row where I is found and the column where I is found. Whatever remains belongs to I. If you do this, you see that what remains is 1, negative 2, negative 2, 3. So these numbers here do not belong to the row or the column where I is found. Therefore, they belong to I. Write them here. We have 1, negative 2, negative 2, and a 3. You close it. Good. Let's now do for the j. Remember, we're using the ijk to break it down from 3 by 3 to 2 by 2. This j here is a minus. Remember the sign constant I told you, the plus, minus, plus. This now becomes minus j. You draw another line. What do you do here? We also repeat the same thing that we did. Now, j is found in the second column. How do we find what belongs to j? You hide the row where j is found. J is found in row 1. Okay. J is found here, row 1. J is also found here. Okay. If you hide the row where it is found and the column where it is found, what remains is 2, 1, negative 2, 3. Write it up here. 2, 1, negative 2, and a 3. We have found what belongs to I and j. Let's now find what belongs to k. To find this, we are going to write a plus k and draw another line here. What do? We also repeat the same process. Where is k found? K is found in the first row. We simply hide this row, okay, where k is found, and the column, okay? K is found here and also here, okay? It's found here. Whatever now remains belongs to k. 2, 1, negative, or 2, 1, 1, negative 2 belongs to k. I said hide the row and the column. Whatever remains belongs to K. What do you have here? 2, 1. We have 1, -2. You close your bracket. Now, what's the next thing to do at this point? What to do is, if you want to simplify this expression here, we have broken everything here down from a 3 by 3 to a 2 by 2. Now, what makes it a 2 by 2? This is 2, and here you have a 2. Okay, you have 2 rows. This is row 1, this is row 2. Okay, this column 1, this column 2. It's called 2 by 2. Okay, to simplify this further, you write your I. Okay, open your bracket. What do you do next? You subtract the minor diagonal from the major. Let me explain what I mean. This part here is your major diagonal. 1 and 3, they make up your major diagonal, while -2 and -2 make up your minor diagonal. See it this way. This is your major diagonal, while here is your minor diagonal. What do? Multiply the minor diagonal together, the two numbers together, and subtract these two numbers from the major. Let me show you what I mean. If we do this, we shall obtain 3 times 1. We have 3 times 1 minus, okay? Let's now multiply the minor diagonal together. I'm going to open a bracket here. You have -2 times -2. We have -2 times -2. Okay, let me put this in a square bracket. We are done with this very one here. Okay, like I said, you multiply your major diagonal, multiply your minor diagonal, then you subtract the minor. See, you can see here, -2 times -2. This is our minor diagonal, while our major is 3 and 1. You can see 3 times 1 minus the minor. We're done with the I. Let's now go for the J. We have a minus J here. We also repeat the same process right here. What do? We also multiply our minor and our major. So here you have the major. Okay, this is our major. 3 times 2. I will say 3 times 2 minus the minor. And what is your minor? You open your bracket. You're subtracting your minor from the major. Your minor is -2 times 1. Here you have -2 times 1. You close your bracket. I'm supposed to use square brackets for everything here. Now, lastly, we are done with this for the J. We now have for the K, we have a plus K here. I'm also going to open a bracket. Let's now do the multiplication. Remember, it's always major minus minor. This is our major, and here you have your minor. Let's now do this. Our major is 2 times -2, which we have as 2 times -2. Okay, minus, you open your bracket, 1 times 1, which is a 1. Okay, now we close our bracket. Let's now simplify. Here we have our I. Okay, we open our bracket again. Let's now simplify. 3 times 1 will give you a 3 minus what's in the bracket right here. -2 times -2 will give you a positive 4. You open your bracket, you write a 4. You now close it. We are done with this. This has been simplified to this. Next up, let's work on the J. We have a minus J. Okay, I'll open another bracket. 3 times 2 will give you a 6 minus, I'll open another bracket, which is this one. -2 times 1 will give you a -2. You close the bracket. And lastly, for the K, we have a plus K. I'm going to open my bracket again. Here we have 2 times -2 would give you a -4. Now, 1 times negative or negative times 1 will give you a -1. All right. Let's continue working on this. We have our I. Okay. Now, what next? If you look at this here, you will see that you have negative multiplying the 4 inside the bracket. What do you now have? You now have 3 minus 4. Negative multiplied by 4 will give you a negative 4. Let's continue. We have minus j. What's right here in the bracket? Negative times negative will give you a positive. Hence, we have a 6, okay, plus 2, okay. A 6 we have here. Negative times negative is a plus. Hence, we have 6 plus 2. Next, we have our plus k. We open our bracket. Negative 4, negative 1 will give you a negative 5. Let's now simplify further. Here we have an I. We open our bracket. 3 minus 4 will give us a negative 1, right? Minus j. What's in the bracket? 6 plus 2 will give us an 8. And for this k multiplied by negative 5 is going to give us negative 5k. Let me simplify over here. I multiplied by negative 1 is negative I. Negative j times 8 is negative 8j. And lastly, we have a minus 5k. Minus 5k. Wow, that was a very long process. You've seen we've obtained a new vector after simplifying all this expression here. Therefore, this is our solution. We now say vector C cross vector B is equal to negative I, negative 8j minus or negative 5k. This is our solution. So friends, this is how to multiply two vectors using cross product. If you have any questions, observations, or comments, you can just drop them in the comment section and I'll be right there waiting for you. If you've not subscribed to this very channel, please do so that you don't miss other interesting videos like this. See you in the next video and bye.